Hello my PU2 champions, welcome back to our channel Deeksha Karnataka. Today I have brought with me the most important, the highest weighted chapter of your PU2 syllabus in Brahmastra 2.0. The chapter is integration. The nightmare of you all student, but I'm here to simplify and help you in that. So let's start the session quickly and we'll see how we are able to counter each category of questions one by one. So first thing will be your understanding of that PU2 is very important. You have to get very good marks, and when we saw the data we were very surprised that only 15 to 20% of students get more than 80%, 85% marks in your PU2. So where are those other 80% of PCM candidates, the students, and why are they not getting this top score even though exam is very simple and very straightforward? Okay, so then what is the problem behind it? And for that we have brought this PU2 target 90 plus crash course. If you are very much sincere, if you're writing this PU2 the coming year 2026, then you should take this crash course. In this course you're gonna get your one-shot lectures, complete PYQ lectures, lecture notes and PDF will be available. You'll have live doubt solving, dedicated WhatsApp community for discussions, and you'll have PU2 dedicated test series as well, which did wonders last year, and all of your seniors recommended this. For all of you, you must take this test series. Will all be included, okay, and subjects covered will be physics, chemistry, maths, biology, alongside with Kannada and CS all together, okay, and all of this is available in 999 means only 1,000 rupees, and everything is available, made affordable for all of you, so that all of you should benefit from this particular target 90 plus crash course and get that dream marks of yours in PU2 boards, because half of the weightage of KCET is taken from here and you cannot ignore this at all. Okay, so link for this course will be given in the description. You can take that right away. Next is your weightage, sir. So if you see the weightage as per your latest blueprint, this is it. You have a total of 6 questions coming, 2 MCQs and rest 1 each from the 2 marker, 3 marker, 5 marker and 6 marker. The total becomes 18 marks. The next chapter after this is 17 mark chapter, which is continuity and differentiability, but over here we have 18 marks weightage. Okay, that's wonderful and very important for us. Next, what are we going to discuss in this particular class will be your category of questions from 1 to 30. 1 to 9 is the MCQs that I've taken. Okay, then there's a 10 to 14 will be the next 5 questions are 2 marker. Question 15 to 23 is 3 marker, 9 questions. 24 to 27 is 3 question again. Again 5 marker we have. So this will be 26 actually, and this will be 6 marker, 4 questions over there. Okay, because you can see 27 and 27 here. No, this will be 26 over here. So we'll change that, no problem. So the total will be total of 30 questions only. Let's continue. Yes, so first we're going to deal with our MCQs, starting the first question right away. This particular problem is a straightforward question, came in PYQ. The year was 2023. You check here, this becomes e power x outside, secant x, tan x plus secant x. I'll write individually. We all know that this is going to be your f of x and this is your derivative. Okay, so answer is we all know e power x fx, so e power x secant x plus c. The property is e power x fx plus f dash of x. If the integration is like this, answer is e power x fx plus c. So option D, right? Option D. Option D is the correct choice. First MCQ is dealt with. Next one. Sin x upon 1 plus cos x the whole square. What are we going to do with this question? This is a substitution based problem. Take this as t. You'll end up with minus sin x dx as dt. Correct? Differentiate, cos will be minus sin. From here you get sin x dx as minus dt. Check this integration now. We have minus dt upon t square. So minus of, what is it? We'll have t power minus 2 dt. Integration, you'll get what? T power minus 2 plus 1 by minus 1 plus c, and this becomes, what is it, sir? Plus 1 by t plus c. What is t over here? 1 plus cos. So 1 upon 1 plus cos is option C, not D. Check here, the sign is positive. Sign is positive. Yeah, super. Next question. This is a definite integral, right? of the form root of, what is it, dx 4 square plus x square. Integration is going to be tan inverse of 1 by 4, actually tan inverse of x by 4 from where to where? From 0 to 4. Check here, when you put 4, you'll get tan inverse of 1, and over here you'll get 0. Tan inverse of 0 is 0. That's why I wrote directly as 0. 1 by 4, and this will be pi by 4. Answer is what? Pi by 16. Option D. Option D. Clear? Yes. Next question. X dx upon x square plus 1. Again, we are looking for a definite integral. Okay, sir. Let's try taking x square plus 1 as t. X square plus 1 as t. So forget about the limits right now. Just take the substitution. I'll get 2x dx as dt. So we have this as dt by 2, x dx as dt by 2. We'll continue as indefinite only. So we'll have here dt. The constant outside will be t, will be 2, and we'll have this as t. Answer is 1 by 2 ln t. Right. Let's substitute back the original variables. We have 1 by 2 ln of x square plus 1 from where to where? From 2 to 3. Check 1 by 2 outside. Put 3 here. We'll have ln 3 square plus 1. So 10 minus ln 2 square plus 1. So 5 half of ln a minus b, a by b. So 2, answer is 1 by 2 ln 2. 1 by 2 ln or log 2. Please check. Calculation, nothing else. We could have changed our limits right there as well over here, but we don't have to. This is a straightforward question. The answer is option B. Next, this is again the same question, right? E power x f of x plus f dash of x. Integration is nothing but e power x fx plus c. Check carefully. This is your f of x, and this right here is your f dash of x. So answer will be e power x upon x plus c. Option C is correct. Option C is correct. Yes. Okay. I hope you are enjoying the MCQs that I have brought for all of you in this session. E power x 1 plus x sine square of x e power x. So okay, again a substitution question. X e power x you take as t, you'll get this as e power x, derivative of x is 1 over here. X as it is, derivative of e power x is same thing, dt over this and dx over here. Check, we have e power x common. I get 1 plus x dx as dt. Integration changes now. dt upon sine square t. So we get cosec square t dt. So we get what? This will be simply cosec square integration will be minus cot, no? Minus cot t plus c. T is x ex. So answer is option D. Answer is option D. Yes. Have a look. Next. 3 cos x plus 4 sine square x. Again a simple question. Separate the terms. Cos x upon sine square x plus 4 upon sine square x. We get here cos by sine will be cot x, and 1 by sine will be cosec x. Over here 4 cosec square x. Am I right? We separated the sign over here. 1 by sine is cosec and cos by sine is cot. Integrate both the terms. We'll get this as minus cosec x over here plus minus plus 4 times of minus cot x. Of course plus c, so we have both of these are negative. So answer is option A. Answer is option A. Yes, sir. Next, Sine power 7x dx minus pi by 2 to pi by 2. This is not a MCQ, but this can be asked in your fill in the blanks also. So this year in the blueprint they have mentioned it as only 1 marker. They did not mention at MCQ and fill in the blanks separately. This can be asked in fill in the blanks or MCQs also. It is a 1 marker question. So the property is minus a to a f of x dx is 0 when fx is odd function. Okay, check here. Sine power 7x is a odd function actually. How come, sir? If you replace x by minus x, so sine of minus x to the power 7 will be minus sine of x to the power 7, which will be minus sine of x power 7. This is nothing but definition of odd function. When f of minus x equals to minus f of x, this is odd function. Hence this answer is 0. Answer is 0. Please check. Next, your last of the MCQ, e power sin x cos x, same rule. This is f of x, f dash of x. So answer will be e power x fx. So option B. Option B. Ninth one, option B is correct. Another PYQ. All right. Now your 2 marker. Now it's time to solve the 2 marker questions. In that, the first one is the very simple one. Separate the terms and integrate individually. We get 2, 1 by cos will become sec square x. Over here we'll have 3. Sine by cos is what, bacha? Sine by cos is tan x, and 1 by cos will be secant x. Of course, both the places has dx in it. Correct? No, we have 2 cos square, so it becomes cos x into cos x. Sine by cos is tan, and 1 by cos is sec. Okay, this will become what? 2 tan x. Integration of sec square is tan x minus 3 secant x plus c. Your 2 mark question. 2 tan x minus 3 secant x. Next, evaluate dx upon 1 plus x square. Dx upon 1 plus x square. Okay, this is a formula, sir. Tan inverse of x from where to where? 1 to root 3. Tan inverse of root 3 minus tan inverse of 1. This is going to be pi by root 3, no? So we have 3 over here. This is pi by 4. Take LCM. 12, 4 pi, 3 pi. Answer is pi by 12. Another 2 mark question dealt with. Next. Find 0 to pi by 4 tan of x. This we know integration of tan is what? Log of secant x. From where to where? Same. 0 to pi by 4. So formulas you all have to know, okay? That is non-negotiable. Otherwise you can't solve any question. Even these simple ones. I did not make this question. They are PYQs, okay? So log of secant of pi by 4 minus log of secant of 0. Sec pi by 4 is how much? That is 1 by root, sorry, that is root 2 actually. So we'll have log of root 2 here. Sec 0 is 1. So log of 1 is 0. So my answer is becoming log root 2 minus 0. Yes. So you can write this as log of 2 power 1 by 2 comes in front. 1 by 2 log 2. 1 by 2 log 2. Next, integral of this. Integral of sec square x plus secant x tan x. Okay, answer will be tan of x plus this will become what? Secant of x. Of course, plus c. 2 marker. Sec into sec is sec square and sec into tan is sec tan, and if you integrate them, answer is secant and tan. Formula if you remember, direct answer. Next, another simple question, looks difficult but it is very very simple. Tan power 4 root x sec square root x and upon root x, answer is what? Take here tan of root x as t. Differentiate sec square root x. Tan differentiation is sec square. What about root x? That's simple. 1 by 2 root of x dx equals to dt. This is the derivative of root x. If you're not sure, do the differentiation of x power 1 by 2. Check. I'm getting here sec square root x by root x dx equals to 2 dt. Equals to 2 dt. We have this form. Check. Yeah. So I get t power 4 dt. Of course 1 by 2 is outside. Integrate t power 5 by 5 plus c. What is t? Tan of power 5 root of x by 10 plus c. T is tan of root x, 5 into 2 is 10. Simple question, another 2 marker. Next we are moving to the 3 mark category. Let's solve these as well. Question number 15. 1 upon x minus root x is there. Okay sir, in this we'll take root x as t. Root x as t. Check here. Differentiate this first. You'll get what is this going to be? 1 by 2 root x 1 by 2 root x dx equals to dt. Can we do better? I can do better actually. I can try that way or this way. Both will work actually. Okay, let's try this. So I can write this as root x common. Then it will become root x minus 1 dx. Yeah, this also works. I've taken root x common in the denominator. So root x minus 1. Now I'll have this d of x root x equals to 2 dt. 2 dt, right? Okay sir, so this form is over here. You can see that. This form is over here. Looks messy. Looks messy. Now this is better. This is much better. So integration, this shall be 2 dt upon root x is t, right? So t minus 1. 2 is outside. Okay, it will become ln of t minus 1. Okay, plus c. Put the value back in. Ln of what is root t? Root x. So root x minus 1 plus c. This is your answer. Looks difficult, but it is actually very easy. Next. E power x sin x. E power x sin x. This is a very beautiful question. I equals to integration of e power x sin x. Not only you have to learn this over here, you need to memorize it as well, because in if you're writing KCET examination, what happens now, this becomes very handy there, because you have to use this directly over there. That's why please understand it right now and memorize it as well. You don't have time to do it again even if you know it that time. Okay, so you got to use the result directly. I'll tell you at the end as well. So we have to use eyelet over here. Algebra has a preference, sorry, we have exponential and trigonometry. So trig has a preference over exponential function. So sin x will keep as it is. And integrate e power x, that will be e power x only. Comes the minus sign. Integration, derivative of the first function, that is cos of x, right? And next we'll have this as e power x integration is again e power x dx. But the problem here is, usually when we deal with by parts, this becomes a simple integration again. But right now this also is another by parts, right? So all right sir, let's continue from here. I sin x e power x we have. Now you can use by parts over here again. So this again rule will apply. Trig has preference over exponential. So we'll keep cos of x as it is. Integrate e power x will be e power x. There comes the minus sign. Now this time, 1 second, sign differentiation was taken, right? So cos derivative we're gonna take. So we'll have here minus sine of x. All right, and e power x as it is dx. Do the expansion now. So I equals to sine of x e power x minus cos of, excuse me, one more step I have to write. We'll write one more step just for better understanding. Cos of x e power x, check here, it will become plus, no, plus sine of x e power x, what do we have, dx. Check carefully, this and this is same. Sin x e power x dx, sin x e power x dx. I can replace this with I then. So I'll get I equals to sin x e power x minus cos of x e power x, okay, and this will be what? Minus I. This will be what? Minus I. Please check. Expand it. Minus this and minus this. It will become I, so minus I. Now move this I on this side. You will have twice of I equals to, take here sine of x. 1 second. Yeah. I can take e power x common in the numerator. I'll have sine x minus cos x. Okay, sine x minus cos x, and this 2 can go over here now. So my final result will be something like this. I becomes equals to e power x sine x minus cos x divided by 2. This is the result that I want you to remember. Okay, got it? So we had to do the by parts one more time. So that's why we had used it over here. Sign change and everything. You can see the steps. I have not skipped any one of them. Okay, the steps are clearly mentioned over on the screen. Okay, sir. Moving on. Important question. Evaluate x sine 3x. X sine 3x. Now, this will be a different story. You'll see. Preference order. I let algebra preference over the trigonometry. So we'll keep x as it is. Integrate sine. So we'll have minus cos 3x. Minus cos 3x divided by 3. There comes a minus sign. Integration. Derivative of x. That's 1. Again minus cos 3x by 3 dx. Okay, check. I have minus x by 3 cos 3x, and this will become minus and minus, so plus 1 by 3 integration of cos 3x dx. So minus x by 3 cos 3x, excuse me, cos 3x, and we have 1, it'll become 1 by 9 sine 3x plus c. How come, sir? Cos integration is sine. 3x means we have to divide by 3. One more 3 is already there. 3 into 3 will become 9. So sine 3x by 9. That's your answer. Check. 3 marker. Next. Evaluate. Check here. This is clear, right? 18th one. Evaluate sine 4x sine 8x dx. Okay. Sine 4x sine 8x dx. Alright, sir. So in this, oh, this is a formula, right? Sine A into sine B. So this is given as 1 by 2 cos of A minus B. So cos of 4x minus 8x. Okay. Minus sine cos of 4x plus 8x. Right? Dx is there. Correct? No, this is formula. Sine A, sine B. 2 sine A, sine B. Okay. Cos of A minus B and cos of A plus B. 1 by 2 can be taken outside. Cos of minus 4, that is same positive only. So cos 4x. Cos minus A is what? Cos A, even function. And cos of 12x dx. Integrate now, bacha. We have cos, cos integration is there, no? So sine 4x by 4. Sine 4x by 4 minus sine 12x by 12 plus c. So we get here by 8 minus by 24 plus c. Sine 12x by 24 and sine 4x by 8. The difference is there. Next, 19th. X square x dx, again in the by parts. So ILAT, you can see the by parts are one of the favorite question of your boards. Okay, it keeps coming. Again, algebra and trigonometry. So we have the preference of algebra. X will be as it is. X square integration will be what? Tan x minus comes here. Derivative of x is 1. Again we have tan x dx. So this is as it is. X tan x minus integration of tan log of secant x. Log of sec x plus c. That's your answer. Log of sec x plus c. X tan x minus log of sec x plus c. Yeah. Next. Dx upon x plus 1. Again, a very important question that comes almost every year for your boards, which is your partial fractions. Sorry, not particular function, partial fractions. So we're gonna make it like this: 1 upon x plus 1 we have. There are more than one form of partial fractions, but most of them, the times they ask this form only, the quadratic form. But you can expect for cubic as well, and I have given that as well in the previous classes. Okay. All right, sir. What about this? So a upon x plus 1. 1 second. Okay, I erase everything. So I'm writing this as x plus 1, x plus 2, a upon x plus 1, b upon x plus 2, a times of x plus 1, b times of x plus 2. Okay, this is your integration. I'm trying to write all the steps because it is your boards. You can see the denominator is same, so I can compare the numerator. Okay, x equals to minus 1 if you put, you'll get the LHS as 1 only. This will become 0, and you'll have b equals to, what is it? Putting minus 1, no? X plus 1 and x plus 2. Yeah. So we'll have over here minus 1 plus 2. How much is that? We'll have the value of 1 equals to plus 1, right? So b value is 1. Am I right? X plus 1 and x plus 2. So we have like this. Next, put the value of x as minus 2. We put it as minus 2. So we'll have 1 equals to, we'll get a times of minus 2 plus 1, which is minus 1, and this is 0. A times of minus 2 plus 1 is minus 1, and that will be 0 there. So I get the value of a as minus 1. Value of a is minus 1. Now you can take this integration. Instead of this, I can take that, no? So I'll have minus 1 upon x plus 1, and integration of again 1 upon b is 1, right? So x plus 2. Both has dx in it. Integration will become minus ln of x plus 1 plus ln of x plus 2 plus c. Log a minus log b is nothing but log of a by b. 2 upon x plus 1 plus c. This is your final result. This is your final result. Please check. Here you go. Yes. Next, question number 21. X square log of x dx. ILATE. I-L-A-T-E. Log has preference over algebra. So we'll keep log x as it is. Integrate x square. So we'll have x cube by 3 minus sign. Differentiate log. So 1 by x. Integrate x square. So x cube by 3 again with dx. This cancel another x as x square. So we are getting over here x cube by 3 log of x minus integration of, what is it? X square dx is left. So x cube by 3 log of x minus 1 by 3. This will be what? X cube by 3 again plus c. Take x cube by 3 common. We'll have here log of x minus 1 by 3 plus c. Check here. I've taken this common, so we'll have 1 by 3 left over here. That's the answer. 3 mark. Find this sin square upon 1 plus cos x integration. Very simple. Write sin square as 1 minus cos square x divided by 1 plus cos x. Integral formula we have. This is going to be what? A square minus b square. For that we have a minus b and a plus b. A plus b will be cancelled. I'll have only a minus b left. So 1 minus cos x dx, answer will be x. Answer will be, 1 second, x minus sin x plus c. For 1 we have x, for cos we'll have sin. The minus sign will remain as it is. Next, find the integration of this. Okay, this is a good question. Integrated bacha, we have e power x outside, x minus 3 upon x minus 1, the whole cube I have in this case, whole cube, and dx. Check. E power x x minus 1 minus 2 upon x minus 1 the whole cube. Separate it over here, okay? Separate it over here. So you'll have e power x minus 1 upon x minus 1 the whole cube minus 2 upon x minus 1 the whole cube dx. This makes sense. Cancels this with square. We'll have e power x 1 upon x minus 1, okay, whole square minus 2 upon x minus 1 whole cube, right? Integral with dx. This is the form f of x. This is f dash of x. Cross check, please. Derivative of x minus 1 power minus 2 is what? Minus 2 times of x power minus 3, right? X minus 1 power minus 3. This is f dash of x. Answer will be e power x f of x. So this here plus c. That's your answer. Done. Next is your 5 marker. The end of 3 marker is done. Next is 5 marker. Over here the the particular functions of your indefinite integral has a big role. So we have to pay attention to those, and to solve these questions we need the application of substitution of different category. So we have x square plus a square. So x square plus a square, when we usually take this as a substitution, x as a tan theta. Since we'll use it, I'll write this also, x by a as tan theta. We'll use it later. We'll use this later. Okay. Substitute it over here. So I had the integration given like this, x square a square dx. Substitute now. We have the derivative as derivative will be bacha dx equals to a sec square theta d theta. So we'll get a sec square theta d theta divided by a square tan square theta plus a square. Correct now? Yes. Check. So I can take this a square common, keeping this as it is. I'll take a square common and outside the root. I'll end up with a outside, and I have over here tan square theta plus 1. Correct? Check carefully. I have a square I've taken out and common, so it becomes a square comes out of root as a. Tan square plus 1 is what? Sec square. Continue. So integration is now sec square theta d theta divided by sec theta. Correct? Because sec square in the root will be sec theta. So this is cancelled. I have only sec theta d theta left. This answer, this integration is a special one. Log of sec theta plus tan theta plus c, of course. Sec theta we don't have, but tan we have. Tan theta is x by a. Tan theta is x by a. What about sec? So sec square theta is given by 1 plus tan square theta. So sec theta will be root of the same things, 1 plus x square by a square. Simplify further. You'll have sec theta as, check, a square plus x square in the root upon a outside. Because if you take root of a square in the denominator separate, it becomes simply a. Now sec also we have, tan also we have. Substitute back over here. So log of sec. First we can write for tan first. So x by a we'll write first. And then we'll write the sec wala part. So we'll have over here a square plus x square by a plus a constant c. You can see here I'm making a form over here. So log of x plus this root divided by a plus c. Separate this log a by b form. So log of x plus root of the same root minus log a plus c. This log a is also a constant and plus c is also a constant. Sum will make another constant. So you have the answer as log of x plus a square plus x square plus a constant k. This is your integration. Log of x plus a square plus x square plus the constant k. Please check. This is the result of your integration. Now we're going to use this question. X square plus 2x plus 2. We have to integrate this, no? 1 upon x square plus a square plus 2. Correct. So we can make this perfect square. We'll have x square plus 2x plus 2 is there, right? 2x plus 2 is there, not this. 2x plus 2. So we get 2x plus 1 plus 1. So I get 1 upon x plus 1 the whole square plus 1. This will become x plus 1 the whole square. So what was the integration? Log of the x. So in this case we have x plus 1 in place of x and plus root, whatever the root was. Here we had x square plus a square. The same comes in the root over here. So we will have the same root. X square plus 2x plus 2 plus the constant k or c of your choice. K or c of your choice. That's your answer. Have a look. Moving on. Find the integral of 1 upon x square minus a square with respect to x and hence find the hence evaluate this value. Okay. X minus a x plus a dx. This is what they are asking. The x square minus a square is given by x minus a x plus a. That's what they are asking. This is the form of partial fractions. Get the result. X minus a x plus a equals to a upon x minus a plus b upon x plus a. Okay, compare this. A times of x plus a plus b times of x minus a divided by same thing. Correct? Right? Compare these two now. So same approach you're going to use. When x is going to be a, what will happen? This will become 0. So you'll have 1 equals to a times of 2a. So value of a is nothing but 1 upon twice of the small letter a. When I put x as a, small a. When you put x as capital A actually, sorry, minus a actually, you'll have value of b as minus 1 upon minus 2a. Value of b will be, check, minus 1 upon 2a. I'll show you. Put x as minus a. This will be 0. This will be 0. This will be minus a. It will become minus 2a. We have on this side 1. So minus 1 upon 2a is the value of b. This integration now actually is integration of 1 upon 2a, the constant, and we have x minus a dx and plus minus 1 upon 2a integration of x plus a dx. So this becomes 1 by 2a is a constant outside. This will be ln of x minus a, and we have a minus sign over here because of this minus. So ln of x plus a plus c. Combine this 1 by 2a ln of x minus a upon x plus a plus c. Plus c. So for the second part, this will be given as, in this case, integration of 1 upon x square minus 4 square dx is there. So you'll have x minus 4, 1 by 2 into a will be 8 ln of x minus 4 upon x plus 4 plus c. This is your answer. This right is your second part's answer. A 5 marker. A 5 marker. Please check. Okay. Next one. Find the integral of the same form. Check here. These two are the same form. 1 upon x square minus a square, asked in March 2022. This is July 2022. Okay, same form. So this part is same as question 25. Okay. What about this part? 1 upon x square minus 8x plus 5 dx. Try to make the perfect square over here. So we'll have x square minus 2 into 4 into x, that is 8x, plus 4 square minus 4 square, and plus 5 is already there. Check. I've written the same thing over there. This gives me x minus 4 the whole square, and this is left minus 16 plus 5. How much is that? X minus 4 the whole square minus 11. Now keep it back in this. 1 upon x minus 4 the whole square minus 11. So 11 can be written as root 11 the square. The formula is 1 by 2a. So 2 root of 11 ln x minus 4 minus root 11 divided by x minus 4 plus root 11 plus c. X minus a, x upon x plus a. X in this case is x minus 4. Please check. Yes, next. So 26 was the last of your 5 marker. Next we have 6 marker to deal with. Let's try. Okay. The King's rule property, we are looking for 0 to a. If you change the x to a minus x, the integration remains same. We'll go about that and then find the value of this particular integration. Okay. So what do we have over here? Check. Proving the property first. So the property is that you're gonna rule change x from. Okay. Wait. Let me write the LHS first. I write the LHS first. I equals to 0 to a f of x dx. We're going to use some type of substitution over here. X as a minus t. X as a minus t. Do everything. Change the limit, derivative, everything you change. We'll get dx equals to minus dt. First thing is this. Limit you change. When x is 0, t will be what? A. X is 0 means t comes here. This is a. When x is a, t will be 0. So limit is changed. When x is a, t is 0. So limit is changed now. I becomes equals to a to 0. X is what? A minus t. So f of a minus t, and this is nothing but minus dt. Write the minus sign outside. This is what? Minus dt, no? Write the minus sign outside. We know very well we can use the minus sign to reverse the limits. We'll do that. So 0 to a f of a minus t dt. We also know that since we have any integration, okay, in definite integrals, I can change the variable anytime. Okay, so let's do that. So I'll get what? I equals to, I'm changing the variable to x to t to x, 0 to a, and now I'll have changing t to x. So I'll get a minus x and d of x. Be careful. I have taken over here substitution. Okay, and this over here I'm doing what? I'm doing changing t to x. This is called as properties of integral. Okay, we're changing the variable. We can do that. So I can change x to t or t to x. I did that. And if you do see this is nothing but same as RHS. This was your LHS. Starting from LHS getting the RHS. Starting from LHS getting the RHS means the given integration is proven. Now the question. Let's do one thing. Let us do one thing. Right here. This as the integration I and equation 1. This part here I'm talking about. Okay. Now I'll rewrite this King's rule. What is this going to be? X replaced as sum of limit is pi by 2 plus 0 is pi by 2 minus x. When you do that, sine will become cos. I hope you know this. Sine of pi by 2 minus x is cos, and same thing, cos of pi by 2 minus x is what? Sine. Complementary ratios. So this integration, if I rewrite, I'll get what? Same limit goes 0 to pi by 2, and sine becomes cos, and here sine becomes again cos, plus cos becomes sine, dx as it is. Check, this is my equation number 2. Now if you add equation 1 and 2, if you add equation 1 and 2, you'll get I plus I, which is 2i. I plus I is 2i. Check the RHS side, limit is same and denominator is same. Limit is same and the denominator is same. Sine plus cos in the root. So sin x in root plus cos x in root, dx is also same. Here we have root sin x, here we have root cos x. Same thing. Root sin x plus root cos x. So we get this whole thing cancelled. I have 2i integration 0 to pi by 2 integration of dx, which is what? X 0 to pi by 2, which is what? Pi by 2 minus 0. So I get the value of 2i is pi by 2, value of I is pi by 4. I know many of you might know the trick, that difference of the limit by 2 is the answer, but it is a subjective question. We have to solve all the steps. It is a subjective question. We need to show the steps over here. Okay, 27 is clear. Next, this is clear. 28. Prove that minus a to a f of x dx is this when it is an even function, 2 0 to a f x dx, and 0 if f is a odd function. Okay, start from here. So I'll start like this. Minus a to a f of x dx can be written as, check, minus a to 0 f of x dx plus 0 to a f of x dx. I'm breaking the limits, minus a to 0 and 0 to a. This is my equation number 1. Also, I am assuming this as the integration I1. This as the integration I1. So what I have for I1? Minus a to 0 f of x dx. In this I'm going to use a substitution. X as minus t. X equals to minus t. X equals to minus t is my substitution. Differentiate, you'll get dx as minus dt, and the limit also will change. We'll check here. Then x is minus a, t will be a. When x is 0, t will be 0. Because I'm looking for x equals to minus t. So my integration I1 will be rewritten as a to 0, the lower limit and upper limit, a to 0 t value, f of minus t, and dt is negative, I can take it outside, no? Dx is dt means I can take the minus sign outside. Same, use the negative sign to change the limits. 0 to a f of minus t dt. This is very, very important. This step is extremely important. Now from here onwards, things will be very, very easy. Let me take you to the odd and even function definition. Odd function, even function. So odd function are those functions where f of minus t is actually equal to f of minus f of t. F of minus t, one second, f of minus t is equals to minus f of t. This is your odd function, okay? And for even function I have f of minus t is simply f of t. So from here I can have two cases for I1, case 1 and case 2. Check here. If it is even, I'll get this as I1 equals to, I'll get this as I1 equals to 0, integration remains same, 0 to a f of t dt, and if it is odd, I'll get the I1 as 0 to a minus f of t dt, okay. Now we know that we can replace the variables anytime. I can change the variable to t to x, no problem, x, okay. Now let me call this as equation number 2. Use 2 in 1. Use equation 2 in 1. Now we'll have two cases. We'll have again two cases. For odd function, for even function. For odd function we'll have negative I1. So if you combine 2 in 1, this will become negative of this 0 to a fx dx minus 0 to a fx dx. I'll have the I1, I'll have I equals to 0 in that case. When you put here negative value, this and this will cancel. You have this as 0, okay. And over here, in the case of even function, they'll be same, 0 to a fx dx, 0 to a fx dx. Over here, 0 to a fx dx. So the result will become I equals to twice of 0 to a fx dx. The statement is proven for even and odd function. Please check. It's proven, sir. For even and odd, both I have proved. Yes, no problem, sir. Have a look. Next, prove that 0 to a fx dx is 0 to a f of a minus x. Okay, this part I have not done, bro. Over here, sorry, this part I forgot. 1 second. Check here, this is odd and this is even. Combination of odd and even is what? Odd only. Answer will be 0. Answer will be 0. This is odd, this is even. Cos of minus x is plus cos x, and sin of minus x is minus sin x with the power odd. It will become odd only. So odd and even is odd. Answer is 0. Next, this I already proven right now. The King's rule. What about this? Same property. If I take this as I, my equation number 1, I can write this as I equal to same thing. Cos will become sine power 5x. Here sine will become cos power 5x plus sine power 5x dx. Limit remains same. Add equation 1 and 2. You'll have twice of I, integration from 0 to pi by 2. This will be what? Sine power 5x plus cos power 5x. The numerators being added, and we have over here same thing, cos power 5x plus sine power 5x dx. This whole thing is cancelled. So twice of I equals to integration of dx 0 to pi by 2, which is x from where to where? 0 to pi by 2, which is what? Which is 2I equals to pi by 2 minus 0, which is pi by 2. I is pi by 4. This derivation over here is done. Please check here, this part. Okay, no, yeah, done here. Okay, this part is the derivations end. Great. The last question, same definition. You can see this is very favorite question of your board, March 23, May, and again March 22. So this question repeats all the time, same property. The result of this will remain as it is. I equal to 0 to a, the given form root x, root of x plus root of a minus x dx. This is your equation number 1. Apply the King's rule. You'll have sum of the, you will replace x by a minus x. So you'll have 0 over here, a over here. This will become a minus x upon, this will be also a minus x, and this will be what? A minus of a minus x dx. A and a is cancelled. It becomes again root of x. This whole thing becomes again root of x, please check. Root of x. Okay, now add the equation. This is equation number 2, right? So add 1 and 2. We'll have twice of I over here, and we'll have 0 to a. If you add these two sum, will get simply cancelled. You'll have only dx left, because root of x plus root of a minus x, here also root of x plus root of a minus x, they'll cancel, only dx is left. Integration will be what? X from where to where? 0 to a. The limit you check, a and 0. So you have 2i equals to a minus 0. So I equals to a by 2. This is the end of your session on your PYQs of the chapter integration. So thank you for joining in and listening to me in this session. I hope you enjoyed it. I hope you learned from it. I'll see you again in the next class. Till then, take care. Bye-bye.